Hi, this is Paola Gomez. Today we're going to talk about face recognition. This is a Calgary competition. We are YCU students, Yuan here in Taiwan. And this is for our class for big data. First of all, we want to talk about what is our overview, what we're going to see, and we're going to have our introduction. We're going to talk about the Keiko competition, what is the preliminary work or works we have found out from other people, what was the problems we had with the methodology, results we got, and our conclusions on what things we could get better. First, you know that right now is very famous that Facebook, Instagram, and different applications have this face detection that when you upload your picture it's already detecting it. So yeah, this is the challenge we got into. Nowadays, image and video detection is a research a mechanism that everybody wants because it's new. It's not something new for computer vision, and even though it's a little bit big and it's not that difficult, so there's many opportunities for improving it. So everybody is trying to get into it. We want to get a faster and accurate way of processing these pictures and detecting the face or key points. The Kaga competition wants to try to track faces and images in video. Also analyzes expression if the person is smiling, if the person is sad, doesn't matter. Or biometrics like face recognition if you go to a camera and detects your face. So remember, this is very different. It can be a 3D pose, it can change the size, position, angle, illumination, so it's a lot of different things that affects it. In the Kaggle competition, there are 15 key points, which represents the following elements like face, the eyes, the eyebrows, the nose, the mouth. These 15 key points are provided in different images. And this is a data file provided with pixels, a row of pixels from integers from 0 to 255, that's the colors. And the images are all 96 times 96. Our training data is 7,049 images, and our taste data is 1,783 images. What we need to do is to predict the location. Well, the main thing we did learn about the Kaggle competition is that not all the key points were there. So we tried to get all the information, and we saw that they were from the images. The only thing we could find out that it was the same was the nose tip. They had the same amount, 7,049, and the image was 7,049. We noticed that the eyebrows and the left and right corners, they didn't have all the information. So we decided to try to find it out in a different way. We're going to explain it later on. So what are the preliminary work we find out? Well, first of all, OpenCity is a big library and big work nowadays for detecting faces and detecting nose, eyes, key points, everything. They use the hard training and we tried to use it, but in my opinion, it had a lot of error rate. We tried to fix it to make it better, but every time he was detecting faces in another parts of the body or in other parts of the picture, it's quite good. Maybe we should understand a little bit more so we could use it. And we also tried to use the one for detecting the eyes, the nose, and the mouth, but it was a little bit difficult to use because the nose got a little lost with the mouth. So we tried to change it, and we decided to use another work. In this case, we decided to go with deep neural networks. Well, with neural networks, what is the problem? It's the regression problem. So we tried to evaluate what is the best way of smoothing it with, in this case, with momentum, right? So there's a different techniques we have. SGD is quite good, but it's too slow. And in this moment, one we're gonna use is nested robes because we think it's the best one. What is the problem and methodology? Well, the main problem is to detecting the percent of images that are complete with the percent of images that doesn't have all the entire key points. And we saw that these all images, the ones that were all the total ones were just 30%, and the other one was 70%. So we decided, let's go with machine learning techniques. We go with convolution networks. And you can see on the side, the picture on the side, how it works. It grabs a set of big metrics and takes information out and starts convolving it. Here you can see a picture of how we're going to use pooling. In this case, we're going to have 3 convolution networks, 3 times 3, 2 times 2, 2 times 2. And we're going to have a hidden layer of 2 layers of 1,000 nodes. We can change it, but we decided to go with 1,000 nodes because it worked fine. We tried with 500. It was too slow, so it didn't train too much, so we decided with 1,000 was quite good. And we're going to get our results. What is the main, what we decided to do? Well, you can see that just 30% is complete, 70% is not complete, and we need to process the information. So for this 30%, we're going to use Nestor accelerated gradient, and for the 70%, we're going to use a classification method. So eyes is going to be just working by itself, eyebrows by itself, mouth by itself, and nose by itself. What is the approach? Well, we decided to use different libraries. We're going to use NumPy, Piano, Scikit-learn, Lasan, CUDA, Pandas. Well, we're going to use different ones for different things. We use, in this case, we decided to use Pandas for data analysis. We decided to use Scikit-learn to modeling, and well, you can see a lot of things. And even though we use also Lasan, here it is. Well, approaches. We decided that because we did have too few information for the 30%, we wanted more information, so we used denomination. We started with flipping the images. We had a method that we tried to use, like cropping, zooming, rotating. The main problem was detecting the key points again. So we decided just to stay with the flipping part that is quite easy, just to change the right eye with the left eye position. So we use this method. Here you can use see a little bit of the code of how we change from position 0 to 1 to 2 to 3 and so on. Because of this, it created a lot of information. We had to use a regularization method. In this case, was the dropout. And the first time we processed the convolution network, we changed it to 10%. The second convolution network to 20, and the third one to 30, and the last one is to 50%. This is a technique so we can stop overfitting. And what we do is just hide some of the visible networks, one of the visible neurons from the network. And you can see part of the code as we talk to you after convolve the first time, to convolve the second one, to convolve the third one, and with the hidden layers. Main problem we had is that we tried to run a CPU computer, it is too slow. It takes usually 365 seconds per epoch, and we changed it to a GPU so we could make it faster to 3.23 seconds. This is a big computer, so it processes a little bit more faster information. So that's why we decided to use CUDA with NVIDIA. And one of the most important things is initializing and momentum in deep learning, as we talk, right? It's a really useful trick for boost deep learning, and it's optimizing this method with momentum parameters. You can see how it can, from normal time, it can change to a better training time. Well, it's backpropagation parameters. So we try to define it with making a pre-training, and with the pre-training, we got a value that will help us do a real value of momentum, a real value for the initialization and learning rate. What was the result? Well, we had to use this method, the root mean square, that was provided by the web page. And the first time we run the information and tried to see how it was going, we we saw it was an improvement, but after we changed some of the parameters, it become better. So we've went from different rankings until the number 13 right now. That is the one we have in the competition, and we got a score of 2.16. The first one is 1.6. Which were our results? Well, the first submission was 0.03, and the second one was 0.05. We changed the linear regression to 0.05, and the third one we changed for 0.02. And without pre-training, we got a really bad result to 2.1754. That's like position number 17. With the first result, we got position 15 and changed the submission to 0.02. We found out we can go 0.003 less, so we improved and we got to the 13th position. What can we conclude? Well, if we don't have a GPR processing method, we cannot run this method for convolution records because it's required. And it is very important to modify momentum and landing rate so you can reduce our error rate and have a bigger result. The database is very important, so if we have more training with augmentation method or including more data sets, it will help us a lot. And maybe we could get a real value or very near to the score. So using these networks are very useful. Maybe we can change and add another neural network where you can train more information, and that's what we want and what will help us to get to the first position. So thank you very much.